Okay, welcome back. You have done already limiting reagent worksheet 1. Make sure you finish 1, 2, and 4. Okay, I will have the answers posted on Canvas right below this assignment very soon. And so in front of you should also have this paper here, limiting reagent worksheet 2. So alright, let's get to this. Alright, first of all, you always start with a balanced chemical reaction. So C3, put a 3 there to get 3 C's on that side. 8H, so I'll put a 4 there to get 8 H's. That gives me 6 oxygen and 4 more here. That's 10 oxygen, that's a 5 oxygen. So 1, 5, 3, 4. Now you have to balance the 2 on the bottom. Well, the middle one's balanced for you, and the bottom, make sure you balance it out as well. And so here, A, limiting reagent, if we review real quick here, if we have 2 starting materials, okay, you have 2 starting materials, you have to set up 2 grids of 2 different starting material going to the same product. Remember, the key is it has to go to the same product, or else how are you going to compare? So the same product you can compare, and the one that's less is the maximum amount that you can use, and the material that produces the least is your limiting reactant. Okay, so in the last video we went over just mole to mole, but this one will go from grams to grams, and just a 4-step per grid instead of 2 steps, just like the mole to mole. Okay, and so here, if you start with 14 grams of C3H8, so we start with 14.8 grams of C3H8 and 3.44 grams of O2, 3.44 grams of O2. Determine the limiting reagent. Okay, so when it doesn't tell you any of them, it doesn't tell you to determine which one it goes to, just pick one. You can go to CO2 or H2O. But if you look down here, it says how many grams of H2O is produced. Later on in part C, it asks that. So let's just go to 8 grams of H2O. So we both go to grams of H2O. So put that at the end, grams of H2O. Grams of H2O. Alright. So remember the order. Grams, mole, mole, and there's grams. Grams, mole, mole, grams. Okay. The second mole is the first mole is the same as this first grams. Second mole is the same as the last grams. So it's H2O there and O2 there. Okay, and we can draw our grid. Like that. Alright, write small because you still remember we still have part C and part D here. I don't think I'm going to have enough space. I'll probably use a new sheet of paper. Okay, but for now, copy the units down. Grams of C3H8 go down here. Copy the units down. Mole of C3H8. Mole of H2O. Don't worry about any of the numbers yet. Just get the units straight. Okay, now the numbers. We've done so much. Looks like a lot of work here, because it is. Alright, so numbers. Mole and grams. How many moles? Oh, let's do the bottom one. It's easier. O2 and H2O is easier. Mole and gram. 1 mole. Oxygen. 2 oxygen. 16, 16. That's 32 grams. Okay. Mole and mole. Where do I go? Equation. Yes. H2O. 4. O2. O2. 5. That's it. Mole and grams. 1 mole. Mass of water. Oxygen is 16 plus 2 hydrogen. That's 18. And you can calculate for the answer there. I won't touch my calculator until I get all my work here done. Okay. So 1 mole of C3H8. C3. 12 times 3 is 36 plus 8, 44. Mole and mole. 4 moles of H2O. That's the equation. And 1 mole of C3H8. Good. Mole and grams. 1 mole of H2O is 18 grams of H2O. So the last step is exactly the same. So that's nice. And so multiply the top divided by the bottom. Multiply the top, so 14.8 times, skip over 1, 4 times 18 divided by 44. Top one I get 187.86. 187.86. 85 grams of H2O. The bottom one, 3.44 times 4 times 18. Oh, that's cool. Equals, divide by 32, and then divide by 5. What? That number's tiny. Did I do something wrong? Did I do something wrong? 1.548. Let's check 1.55 grams of H2O. Something's not right. 3.44 grams of H2O. So 14.8, I'm checking the top math here, times 4 times 18 divided by 44. Oh, the top was 24.21. Silly. Can you do this? I don't think so. Just erase. Alright. Let's try that again. 14.8 times 4 times 18 divided by 44. 24.22 grams of H2O. Okay, let's check the bottom one again. 3.44 times 4 times 18 divided by 32 divided by 5. Yeah, 1.55. Alright, so we can only make 1.55. The one that's less is, that answers part C. Part C is 1.55 grams of H2O. Okay, this also answers part 1, which one's the limiting reactant. Which of the two starting material produces less? It's going to be the oxygen. So you say oxygen will run out. The material, we don't need the number. It says which one runs out first? Oxygen. Okay. Determine the number of carbon dioxide. Determine the number of moles of carbon dioxide produced. So there's just more questions here regarding this thing. You get a new sheet of paper here. There you go. Part B. So now we know that we run out of oxygen. So from now on we start with that. Or for this question we'll start with that. 3.44 grams of O2. And then we need to go to, remember it's grams, mole, grams here. And it's asking for what? Part B. How the number of moles of carbon dioxide. So just mole of CO2. So we don't need that last grams. Okay. So there you go. Mole of O2 go in the middle. Keep in mind the mole changes right here. Mole and mole, they're not the same thing. Okay. Mole of oxygen, mole of carbon dioxide. There's going to be a different substance. So copy down here. Grams of O2. Mole of O2. That's a lot of these you already have the numbers for. Mole of O2 is 32 grams. Exactly the same as that part right there. Mole and mole, that's easy. Look at the equation. CO2 is 3, O2 is 5. And that's your work. Remember, all the units cancel out. Just like up here, I should have done the same thing. Cross out all the units except the last one on top. Okay? Just looks messy. So 3.44 times 1 times 3. So there we go. 3.44 times the top times 3. Divide by 32 on the bottom. And then divide by 5. So I get 0.065 mole of CO2. That's a small amount of moles. It's very small. So then that's part B. 0.065 mole of CO2. Okay. Oh, now this is tough. D is a little more, conceptually, it's a little more challenging because we have to think about it. Alright. Part, we know that what's known is we produced 1.55 grams of H2O in this reaction. Yes? Okay. And we know we want to know excess. So of the two, if we run out of oxygen, what do we have excess of? We have excess C3H8, right? We have excess C3H8. And we have 14.8 grams of C3H8. Okay, we need to know, in order to know the excess, we need to know how much we used. So once we know how much we used here, we can determine the excess, subtract to determine the excess. So this is another problem in itself, but it's the same equation. Alright, so here we go. So we know that's how much we produce, so 1.55 grams of H2O. Okay. Grams of H2O, we need to go to grams of C3H8. Grams, mole, H2O. I'm sorry, mole of C3H8. Oh, crud. Oh, crud. And then grams of C3H8. Oh, God. I'm going to start this over because there's not enough room here. Okay. 1.55 grams of H2O. Grams, mole, grams. We're going to grams of C3H8 because that's how much we want to find out how much we used, okay, to make that much H2O. So grams of H2O. Oh, sorry, mole of H2O here first. Mole of C3H8, the second mole, the second substance. Mole of H2O go down here. Mole of C3H8 there. Okay. We've done all this already. Just find these numbers that we've done. 1 mole of that is 18 grams. C3H8, the relationship with C3 is 1 C3 to 4 water. That's cool. And 1 mole of C3H8 is 44 grams. We did it already. We don't have to. So the nice thing is, when we stick with the same problem, we don't have to calculate the mass over and over again. It's already done. All right. So then we do that. Solve the problem there. 1.55. Dang it. 1.55 times 1 times 1 times 44 times 44 divided by 18 divided by 4. Wow. So we only used 0.95 grams of C3H8. Isn't that crazy? Isn't that crazy? So if we only use that much, 0.95 grams of C3H8 used, subtract it and you'll find the excess. 14.8 minus 0.95, and you get 18.85 grams of C3H8 excess. Okay. That answers part B. Okay. A lot of work here. So, but again, it's repetitive. It's grid. The concept is, again, a couple of things here. The first thing, set up 2 grids. Okay. And the one that gives you the least, the ingredient, the reactant that gives you the least, with least product, is the limiting reagent. The other is the excess. And so the reactant that gives you the least is the product, and the lesser of the two, product is the answer, is the maximum. The maximum product that can be produced. Okay? 3, use the lesser of the two product to figure out, to find how much of the excess material is used. Okay? Use the lesser product to find out how much of the excess material, which is the other material, and then subtract what you have, minus used, equals the excess amount. So the concept is basically that. Okay, set up 2 grids, grams, mole, grams. The reactant with the least that produces the least product is the limiting reagent. The least product is the maximum that can be made. So use that amount to figure out how much you use of the other substance, and then subtract, find your excess amount. That is it. Complete number 2 and number 3. Again, if you don't have enough space here, use a separate sheet of paper. Staple it onto your work so to show that. Okay, balance these equations first. It might be helpful to go ahead and find the mass of these things before you start, because this compound is a mess here. Let's do a no. I'm not gonna do a couple. Good luck. Goodbye. Finish it.